opted to build an array list instead of an array, what kind of thought process did you use to build an array list instead of an array?
Add to the array list. Right?
Yeah.
I tried it with the new int. I kind of got stuck on how to add it to it. So,
Well, it makes sense that you got stuck because it's impossible to resize an array. So you have to know ahead of time how many integers you need, which you kind of do, but it does make more sense to like gradually just add on to the array. Because like when you pass in x there, that's the number of integers you're going to return in the array. So you could be like new int 7 elements. Like you wouldn't be adding to the array list or the array. You'd just be setting the element at that element, setting the value at that element. See what I'm saying? So it's not impossible to do with an array, but it is. I agree with your decision. I think it makes a lot of sense to use an array list. So your approach here, I would say, if you're looking for some feedback, I would say that x is kind of a, I think it's a parameter name. Is that what it says in the? If we were rewriting this program, we would probably want to name x something that makes semantic sense for the problem we're trying to solve, like number of fibs or something like that, fib number or something. So you know, you can hit like Shift F6 and it'll refactor that variable name. Yeah, so like every time, yeah, if you want to undo it and try it out, you can check it out. Well, you need to Command Z that also before it'll take effect. Hit Shift F6. There's that red box. So it's going to take every reference to that variable and update it for you. Yeah. You tell it rename it, yeah. Right? Pretty cool. It's pretty cool for local variables, but it's really cool for like methods and stuff because like you have no idea where your methods are being used. The alternative would be to like find usages of the method and then look for all the compile time errors. To do that. So some more feedback. I would say that this if is not really super necessary. Always going to be going that path if you're not going the other path. So it's just one little. And also, this return results probably should go on this online, but that's kind of nitpicky. That's like white space readability stuff. But again, the most important thing is you solved the problem, and you did. So that's awesome. Does anyone else want to share their solution? All right, let's just hand me the cable, and I'll kind of go over how I would do this. Normally, I would do this while you guys are working, but that's kind of a later start. I'll just go ahead and do it in front of you.
You're gonna think out loud.
Sure, but I also want to show you guys a cool new thing while I'm doing this. So. Okay, so I've opened up my Scratchpad. Yeah, I'm sharing my screen. That's good. Fibonacci sequence. So the first thing I want to do is actually write a test for it. Here, I'm actually going to comment out this funny Nemo test because I don't want it anymore. We're going to write a test. The public void Fibonacci sequence generator generates valid Fibonacci arrays. So there is a JUnit method called array equals, which will compare arrays to their contents. So like, it'll check if their arrays are the same. So I'm gonna do an expected value of like new int 1, 1, 2, 3, 5. And I'm gonna do main.Fibonacci, then assert array equals new int 1, 2, 3, 5. Well, actually, let's do this so we can test some edge cases. All right, so I have a few tests here. I'm going to move this stuff here so these longer ones are next to each other. Yeah, good job, guys. That's it. All right, so we have assert array equals on 1, 1, 2, 3, 5, 8, 13, and then 1, 1, 2, 3, 5. I have 1 and 1, 1 here since those are the other real edge cases. We have like a couple different kinds of Fibonacci sequences. Like with length 1, we don't add anything together, it's just the first element. Length 2, same thing, except for it's just 2 elements of the value of 1. Then for everything else, it's just together. So we're tasked with implementing this. What we're going to do, I'm going to have a public static int Fibonacci method that accepts int max length, right? That specifies that I'm going to return an integer of Fibonacci's with an integer array of Fibonacci's with a specific length, right? So I'm going to return new int 1. So it compiles. You can see I can get one of my tests to pass. Oh, I deleted my. I don't want to run Funny Nemo anymore. I want to run main test. Wait, what? You go away. All right, so all failed. So that's good. That means that my tests are working appropriately. Just for giggles, I'm going to put this up here. So it's the first thing it passes. So the first one's going to pass, and then the rest ones are going to fail. Okay. So my approach is going to be very similar to Jennifer's, except I'm going to make a couple different tweaks. All right. So what I kind of want to do is, first thing is generate our results array. So I know how long this array is going to have to be. So int results equals new int length. Right. So that generates, that allocates enough memory for an array of length. Okay, so we're going to put all of our Fibonacci numbers in there. So the rest of this could be very similar. So for int I equals 0, I is less than length, I plus plus. If I is less than and results at I is equal to 1, else results at I is equal to results at I minus 1 plus results at I minus 2. Turn. We run our tests. Uh-oh. Say what? 1, 2, 3, 4, 5, 6. Yeah, you're right. And it's not on my test writing game today. It works. So this is one way to do it. However, a cooler way to do it could be this. So let's see, 2int integer. All right, I'm going to define my own functional interface because I want to make a Lambda expression to store this method. Build an interface called like array int function. It's called a functional interface, which means we're going to use it in the context of a Lambda expression. So it's going to have one method that takes in an int. We're going to call it apply. And it takes an int array and it returns an int. Okay. What I can do here is say array int function test equal to array return if So let's change this to generate the ith element. This is a little bit contrived, but I just kind of still wanted to show you this example, right? Because this is a cool thing to do inside your repeated pattern. You can use a Lambda expression to accomplish the same task. So say I want to build, I want to return the last two. So I given an array of numbers, give me the ith Fibonacci number. Okay. Let's actually, instead of test, let's call something better like fib generator. Okay. So if I is less than 2, then return 1. Else return array at I minus 1 plus array minus 2. Okay. So we could say fib generator. So we could say results at I is equal to fib generator. Results f fib generator dot apply results at I. Yay, it still passes. So what happened there? Well, first I went and I made an interface. It's a functional interface. Whenever you see functional interfaces, it's like a way to generate Lambda expressions. This specifies that we have a method called apply. It takes in an input and it returns. So it takes in an input and the index that you're trying to find and returns an int. So I might want to actually rename this. It's more specific to this. It's like fib int index array function. So given an array and an index, return an int, right? So here in our Fibonacci method, we make a new results array of length. Next array function. Note that since I refactored it by hitting Shift F6, I didn't have to rename this also. called fib generator. A function that's going to accept an array in an index I and then return something. It's going to return an integer, right? Less than 2, return 1, and then otherwise return array element I minus 1 plus array I minus 2. I don't want to do that. So just so you're aware, I'm never going to recommend this, but if you have a one-line statement inside of an if or an else, you can omit the curly brackets. My experience, omitting curly brackets leads to confusing issues, so normally but I want to let you know that it's possible. You'll see it in the code that you come across in your professional careers. People will omit the square brackets or the curly brackets, but so you get into a case where like someone omitted the curly brackets and then they meant for the next line to also be a part of the if statement, and then causes all sorts of weird bugs. So, in general, you should probably ignore it. So yeah, in this for loop, basically, I delegated all the responsibility of actually finding the fib numbers, this function here, and I just called that function on our results array and I over and over again. Cool. You could also have a recursive solution to the Fibonacci sequence. Avery, did you do the recursive solution?
I didn't do the practice problem today because I've done it in Project earlier.
Okay.
So.
Okay. Yeah. Cool. Okay, so good job, guys. Practice problem. Before we get started, does anyone have any questions that you want to talk about before we get to our lesson for today? Or anything like that?
The assignment where we had before something, the assignment for Monday. Go ahead and turn on the online.iron web page my pull request link.
Yes.
Okay.
Yep. So because of what we did last week, sorry, is there anything else? Okay. So we talked about this stuff last week. HTML versus JSON. We talked about JSON-based APIs. We talked about RESTfulness. RESTful API, basically an endpoint that returns JSON instead of an HTML web page and has different request verbs. We've been using those request verbs in our assignments recently, like get and post. And there's more like put and delete, patch, and stuff like that. So we have done some of this. So if we get far enough, I kind of want to dive a little bit into next week's material today as well, if we can. But first, I want to make sure we reiterate what's going on today. So today's lesson is supposed to be about HTML and JSON. Right? So are you guys clear on kind of the difference between HTML and JSON and all that stuff, right? We built APIs, we built web pages.
I thought that JSON was like the file format for HTML and the Java API. Like I thought it was merge them.
Not really. JSON is really language independent. It's not a Java thing at all. HTML is not a Java thing. JSON is not a Java thing. JSON is like if you have data that you want to represent and transfer to a client, JSON is a great way to transmit that data to a client. So,
But is HTML, what is HTML, how do you compare like HTML and JSON together? Wouldn't HTML be like a language that we, and JSON would kind of be like a file format that we put in?
Not really. Technically, HTML is also a language that semantically describes data, right? So you're describing data in both cases. So they're very similar. HTML and JSON, they do a similar job, right? So that might be what your confusion comes from. In practice, how they're used is completely different. So like, if you hit a web page that returns JSON, you need to write some JavaScript that uses that data inside that JSON and does something meaningful with it. Page alternatively that returns HTML, the browser is going to see that HTML and it knows how to like display it. So like the HTML is, it's going to download the HTML and the CSS and the JavaScript to add dynamic functionality. So while they both serve to describe data, when they're used, they do different things. You don't frequently parse HTML to just look at the data. You use HTML to have like it's called a box model, basically lay out things on a page. Okay?
So what we use JSON for?
Yeah.
So we wrote our, so let's say we wrote our Java application. Then we put that into JSON if we wanted to, like in the example where we have our front end and back end working together.
Yeah.
You can put it into JSON and then send it to some guy that's using JavaScript and you'd be able to use it.
Yeah.
So that's basically, that's like the whole purpose.
Uh-huh. And it's not even just JSON, or not just JavaScript either. Like if you have like someone who has, like if you have a Java web app, and then you can expose your data on a URL at some point, you don't know how they're going to consume it. It could be like some dude who's writing a .NET app, like sees your data and is like, oh cool, I have this data, I can use it. The whole point is for the people who consume it to not know anything about who's producing it.
So every single time, like it's currently, like every single time we make an API, we should put it in JSON.
Yeah, JSON is an extremely popular data format. The only other alternative would probably be XML, and there's another one that people sometimes use. It's called YAML. So, but a lot of the time, JSON is the de facto standard for building APIs and sending data back to a client somewhere. So, but I want to make the point that when you look at a web page, you should not care about the server that generated the web page. Last time you looked at a web page and was like, oh, this is a Java-based website. And sometimes it's pretty obvious because there are web pages that end in .jsp. I'm sure you've seen that. Went to a URL and it's .jsp. It stands for like a Java servlet page, which is a kind of an old school way of doing things. But if you just see a random URL like google.com, you have no knowledge of what backend server went into making that. The same is true for JSON APIs. That's the whole point, is to provide a level of, the server's job is to give you JSON and that's it, right? And then the consumer just uses that data exposed by the JSON to do whatever Java needs to do. Yeah. Cool. All right. We're going to look at a different way to generate HTML elements on a page. So before, when we made a web page, we were using the Mustache templating engine on the server to generate whatever HTML we wanted, right? Today, we're going to set up an endpoint, an API endpoint that exposes like a JSON array. And then we're going to, in JavaScript, create those elements based off the data that we see. And we're going to add it so it just checks the server every few seconds for new elements and then add them appropriately. Okay? So we're going to dive a little bit into JavaScript. JavaScript is a favorite topic of mine, so I think it's wildly interesting. And you can kind of compare JavaScript versus Java in a way also while we're at it. Okay, so just to reiterate, the old way is you get a request, the server returns HTML, and the browser refreshes the page to get you the HTML that you asked for, right? So the new way that we're talking about today is we initiate a request from JavaScript. It's called an AJAX request. You guys ever heard of AJAX? AJAX is a pretty common acronym. It's JavaScript and XML. So that acronym was made before JSON hit the scene. Because back in the early days, no one knew what kind of data transport language was really going to hit the. So really, it's AJAX. Because in most cases, you're going to be consuming JSON, but it's the acronym stays the same. So you're going to initiate a request, and then the server is going to return JSON, and then JavaScript parses that data and injects it onto the page. So it's going to interpret whatever data you get back, elements, and then apply those elements to the HTML on the page, right? Okay. So that being said, we're going to create a new project called AJAX Chat, okay? So if we take a step back and think about what we're writing here, it's pretty cool. The AJAX-enabled web page that automatically refreshes items as we add them. All right, so to this, we're going to add H2. We're still using H2 for this. I always like to download the sources for these, considering how much I like to dive into the source. It seems like a good idea. We have H2. And it spends 1.5 years resolving Maven dependency. We have Spark. And we have the JOD library that we've been using for our JSON. Chug, 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 chug. Then we have JUnit. Okay. All right. So if we're going to write a chat program, the thing that the chat program reasons about is messages, right? So in our message class, we have an int ID, we have an author, and we have text. It's very similar to our forum web class like we had before, except there's no reply ID. A physical thing that we can reason about, we should probably make a class for it. So we're making a message class to talk about the messages we're sending back and forth. So here we have a public class message with 3 fields and a constructor that sets those 3 fields. Right. So we're going to be sending message objects back and forth. You good, Mike?
What do you use as a passive trigger? So
I think it's arbitrary, but integer in this case is nullable. Probably could be either. In most cases, it can be either. So yeah, we need to create the getters and setters for our fields because the JOD library uses getters and setters. So let's go ahead and make these fields private. The getters and setters for the 3 fields. There you go. The next thing you do is create your database. So this should look familiar. The past couple days we talked about databases, right? So create tables is a static local method. Can be made private. It operates on a connection, and it can throw a SQL exception because we're hitting this execute method right here, right? So execute, I believe, is the one that, yeah, it throws SQL exception. So we're creating a statement from our connection, and then we're executing that statement. And the statement that we're executing is create table if not exists, messages, ID, entity, author, varchar, text, varchar.
Why is this one not prepared?
Yeah, so this one has the option of not being a prepared statement because we're not going to be passing any variables into the SQL statement. So we would use a prepared statement in the case that build a SQL query based off of another variable. So we use prepared statements to protect us from people putting like bad data in our database. In this case, it's not necessary because we don't have any, like, it doesn't, the SQL query is not dependent on any variables. It just is, it is what it is. So there's no way anyone could inject back into this. So yeah, right here, we're going to start our web server, our H2 web server. Connection to the /main database, and we're going to call create tables on that connection that we generate. Messages table and run our web server. So check it out. Spark does have this is a Spark web app, by the way. We're going to be using Spark to deliver our page and our API. So Spark has a method called external static file location. That's basically setting the public directory as is where we're serving static files from. Strange. We'll go over an example in a sec. Actually, right now. So let's add a public folder here. So add a folder here called public. And then inside this, say we have a file called like index.html. With a title like test index.html. Go world, save it, and run it. So Spark is running, H2 is running. We go to localhost 4567. Goes hello world. So it's by default it's rendering index.html. So just as a test, we could also do like test.html. Then we write some quick HTML here, like here, hello from test. I'm gonna rerun it, I believe. Index.html, and we also have test.html. We didn't define any routes in our main.java files because these pages don't require any logic. Like these aren't mustache templates. These aren't things that pull data from a database somewhere and render HTML. This is just we've configured our server to just return the contents of these files in this directory. So the public directory is a pretty common thing in web apps. It's where you store all your static assets. A static asset would be an HTML file or a JavaScript file or a CSS file or an image file, right? So those don't require any server-side processing. They just need to be accessible via a URL. So you just the server just returns that file as is to the client, right? So a lot of people will have folders like and CSS. And inside this, you would have maybe like style.css. And inside this, you might have app.js or script.js. Right? So we'll just do like script.js for now. Cool. So by the way, index.html is kind of a, anyone remember GeoCities back in the day? Right. I made a GeoCities. It's the first time I ever heard of index.html was GeoCities because Apache, I believe, is what GeoCities used. Index.html is kind of the de facto standard historically on the web for the home page. Like if you go to, when I went to localhost 4567, I didn't have to explicitly go to /index.html or a file called index.html and just served it to me. Right? Historically, if you see index.html, it's kind of the default document for a given URL. Okay. Like for our homepage. All right. So we need a chat.js that just contains this. Okay, that's kind of annoying. For now, we're going to create this chat.js script. So chat.js just has an alert. So the next thing we're going to do is download this thing called jQuery. Have you guys ever heard of jQuery? Sure. Sometimes no. So the thing about JavaScript is that, and this is the thing, it's common to all of the internet. You know, the browser that you use to look at web pages has a lot to do with the experience you have on that website. Different browsers support different things. So there are standards nowadays, like HTML5 standard, CSS3 standard. There is a W3C specification for JavaScript called ECMAScript now. But it's all like when you use a program, it's up to the person that writes the program how they implement those standards. So back in the day, when the web was first getting started, standards were still being generated, like people were realizing the need for those standards, but meanwhile, people were writing software that like did whatever they thought was best, which was totally arbitrary. So like Internet Explorer, you guys have used Internet Explorer before. Back in the day, like in Windows 95, it dominated the marketplace for web browsers because it came default with all Windows 95 systems. I think actually it came default on 98 systems and 95 plus, right, which is an extension to Windows 95. But regardless, Internet Explorer sucked. Right? It was the worst. But it dominated the market share. But the features that supported were very, very minimal. Historically speaking, that's been the case for Internet Explorer since its inception. It's been just historically very bad web browser for developers to use. It doesn't support a lot of the same JavaScript features or the CSS features. You have to make special edge cases around working with Internet Explorer in your CSS and your JavaScript. It's a huge pain in the butt. So like nowadays, people are like, this works on all modern web browsers. That is every browser except for Internet Explorer versions like 9 or before that, right? So Microsoft has kind of recently, after like 2 decades of just fumbling this problem around and messing it up completely, has finally kind of got with the program and has implemented standards in an appropriate way. So now Internet Explorer Edge is roughly, it's about the same, right, as a modern web browser. So Chrome nowadays is probably the de facto standard for goodness. So back to this, jQuery, back in the day when there was no guarantee. Like if you looked at a bar graph of the things like the JavaScript features that were supported by every browser, if you wanted to like deliver your web page to all your different clients, you needed to be able to account for the browser they were using and still deliver a good experience, right? And that was a very hard job to do with just JavaScript because you have to know a lot of these different edge cases, like, oh, if you're using Internet Explorer version 7, you need to add this one thing instead of this other thing. So this guy wrote jQuery to be like, you know what? Just include jQuery and then use these jQuery methods instead, and then jQuery will do the job of figuring out exactly how to interface with all those browsers. It kind of removes the need for writing all of this code to determine what browser they're using and do different things appropriately. And also it has like a ton of really useful helper methods that make writing web applications way simpler. So we'll be using jQuery today. We'll talk about like what the different methods mean. But jQuery just kind of like makes your JavaScript writing faster and easier. Okay, so writing raw JavaScript, you're writing. It's like a lot like the difference between most programming languages and Java. If you think about it, like jQuery in the JavaScript world is like the JVM in the Java world, right? Because the JVM handles all the different computer-specific stuff, and you just write one application that uses the JVM, right? And with Java, you just write in jQuery, and jQuery handles all the implementation details of the different browsers and stuff. So it's a very similar concept. So I'm going to download this. This is jQuery 3. We're going to just copy the contents of this file. Make a new JavaScript file here called like jQuery 3.1.0.
So when I click download it, it just turns it into a file in my browser.
Yeah, you just copy all that text and then save it to a .js file in your public directory. So we have jQuery and we have chat.js in our scripts directory. So you have chat.js and jQuery. jQuery is a pretty big language, by the way, or it's a pretty big framework. Like we're on line 4,000 right now. This is a 10,000 line program. It's not even that large comparatively. So like if you look at the Chrome new tab window, and you look at like the console here, let's see here. Actually, this is the network tab. Type script. This is a minified JavaScript, which is like a very shortened version. That's 400 lines right there. This is another 80. This is 600 and something. So length of code it varies. It's all over the place. So anyway, jQuery is a pretty big language. It's very helpful though. So once we have jQuery downloaded, we can include it in our HTML. So for our index.html, we're going to include it into our page like so. Except we have make a couple changes to this. We downloaded jQuery 3.1 instead of 3.0. And then the location of these scripts is in the scripts folder. When the browser gets this index.html HTML back, it's going to process this line by line, just like any program is executed. So it's going to run this head element, and then it's going to get this meta tag and just set the current char set for the request. It's going to get this title tag, and it's going to use that to set the title of the current tab. And it's going to hit this script tab, or script element, right? It's going to see that in order to resolve this, I need to go here and try to get this. So this is what's called a relative path. So this is going to go, like if I go to this URL, it's going to go to the script's jQuery 3.js URL. Right? So I don't have to specify the host name or anything. I just say that, and it'll go to the current URL, scripts folder, jQuery. So it's going to go and retrieve that jQuery. It's going to make a new request to the web server to go get the JavaScript. And it's going to return that JavaScript back, and then when it's done returning it, it's going to execute it. So after it executes, jQuery is a part of your current page, right? So the next thing it does is it goes and it does the same thing for chat.js. Now, chat.js is a really contrived example, and it's not yet. So it's going to execute that JavaScript, which just runs an alert function. Okay. Just do a quick test here. There we go. You see that this is what an alert looks like. An alert is a JavaScript function that just like makes a pop up that says hello, or it says whatever you say it to say. Okay, so once you say OK to the alert, we have our page here, right? Then look at, we have a problem here. jQuery 3.10.js, jQuery, oh, yeah. Wait, really? Wow, okay. Yeah, we returned our jQuery and our chat.js, so we're good. So we're all set. So the next thing we're going to do is we're going to create our tables for our messages. We're going to insert those messages and be able to select those messages. So again, we're just putting things right here in our main class. Open up main. We have create tables here. So Joy, back to your question before, we're using a prepared statement in this case because the statement that we want to execute against the database engine has these variables in it. So like, instead of building a string that concatenates two variables together, we build a prepared statement, which injects those variables into the SQL query. So the difference being that when you inject it, it like safely injects it. So you're not ever worried about them giving you bad data, injecting your database. Okay. So the job of insert message, if we take a look at the method signature, it's very similar to what we've seen before. Insert message doesn't return anything, so we don't care about the return type of insert message, so it's void. But it does take in a few parameters. It takes in a connection, an author, and a text, and it prepares a statement which inserts an author and a text into our messages table. And correspondingly, we have a select messages, where it just gets all messages over a connection. So we have an array list here. We're going to be putting all of our messages that we receive back. We're running a new prepare statement. You could use the statement here as well. So you get a result set back, and then you iterate over your results. And then for every result you get back, you get the column int ID would return you an int, which is the ID. And you add a new message object to your messages array list, right? That's how, and you return the array list. So that's basically getting all the messages from your database in this select query. Good? All right, so now that we've added our data, like our schema, our database schema, and our insert and select methods, we can focus on Spark and what we do through the web front end. So we have two endpoints here. We have a get endpoint, which is just get messages. And we have a post endpoint, which is add message, right? So we need to have a get author here, and then get text. We made our fields private, right? So get messages is going to return the serialized messages array list. So the first thing this does is it gets all the messages out of the database and returns it, and it makes a messages variable, and then it uses the JSON serializer to serialize those messages into a string, and then returns that string. Yeah, select messages is a method that takes a connection and returns an array list. String. That string is formatted in JSON, and we're sending it back to the client. In this one, in this post request, we're getting the request body, and then we're using the JSON parser to parse the body as a message object. This is going to be JSON that looks like a message. It's JSON coded, like it's going to be in the JSON format. And then we're using the JSON parser to parse that data into a message object. Right? Okay. And then we're calling our database's insert message here. Connection. That gets the body of the request. So like when you when you receive a response back from the web server, there's a response body that is like the HTML or all the data. The server, that's in the request body. So like when you make a request, you can include with it data. Okay? And then sometimes that's form submission data, like when you submit a form, or other, like in this case, it's going to be JSON. So we're going to use JavaScript to submit JSON to the server. The request.body in this case just gives us the contents of whatever was sent up as a part of the request. Yeah, so standard GET requests don't have anything in the body. This stuff, I'm not going to give you any data, just give me the stuff. But post requests will frequently have data in the body, which is the stuff you're posting to the web server. So once we do that, we call insert message on our message object. Well, we call insert message on our connection. We pass in connection, and then the get author string and the get text string. Okay, it's a message to our H2 database. So check it out. What we're going to do here is add a couple input fields and a button to our web page. The lesson here says that we don't need a form element because we're doing all this inside JavaScript, but we're going to add one anyway. But that's not how I roll. Really interesting. What you guys doing? Really cool stuff. That's really awesome, and not related to what your class is doing at all.
Okay, well, maybe another day then.
Yeah. Okay. So, yeah. So check this out. OnClick is a way to specify that a JavaScript function should take place. Button.
Okay, so add messages in JavaScript.
Yep, but we haven't defined it yet. Like, so we're going to put that in chat.js. Yep. So, like Nostradamus, Mike predicted that we were going to be doing this. So check it out. So we're going to replace our hello world call here with an add message function. Okay. So we see here, this is JavaScript, right? So a function add message is JavaScript. So this is how, let's see, define a function in JavaScript, period.
So just what you call functions and pretty much same.
Same thing. The difference between a function and a method is that a method is a name for a function that works on an object.
Could you say that last part again? Is that a method?
Is a function that works on an object. A function and a method, I've used them interchangeably and I've corrected myself maybe like 1,000 times in lecture so far. It's because the relationship between functions and methods are that they're basically the same thing. But technically, from the object-oriented programming standpoint, a method is a function that is like that operates on a specific object. Yeah. So here's how you define a function in JavaScript. Pretty simple. You don't have to tell it what the return type is, like you'd have to do in Java. And this function that accepts no parameters, and there's no guarantee as to what it returns. It could return anything. Okay. So if we look at the contents on line 2 here, we're defining a message object. In JavaScript, this is how you make just an anonymous object. So this is very similar to JSON. So you can think of it like JSON. The only difference really is that this is not in quotes, like a JavaScript object, JSON, right? And then it contains the open curly bracket and then a key and then a value. But the keys in the JavaScript object notation are not in quotes. They're not strings. They're just text, right? So the thing, this is jQuery. So when the JavaScript runtime creates this object, it's going to create an object with the key author, and it's going to run this val method here to figure out what should be here as the value. So we have this $, which when you see the $, a lot of the time that means that you're using the jQuery library. Like this is a big indicator of jQuery is the usage of this $. The $, is a function in jQuery, and so you invoke the function the same as you would in Java with the brackets. The $, function takes in a string, a selector. Okay, so we haven't talked about CSS too much, but in CSS, if you wanted to get an element with a specific ID, you'd say hash and then the ID name. In HTML, our ID here on this element is author. Okay, so this is basically saying give us the author element right here. This is a text field, and then val is a method that jQuery has for input text fields that gets us whatever the value is of that text field, which is whatever you type in. Right. So effectively, the author is going to be whatever the contents of the author text field is after this runs. And then the text is going to be the contents of the text field. Okay.
So how is this doing this different than doing it in HTML? Why?
Where it's run. So historically, when we built our apps before today, we would, on the server, be generating all of our HTML and then sending the HTML back to the client. Right? So the web page, after the server gives you the web page didn't change at all. It just is what it is. Okay. You are generating like the skeleton on the server, and then you give that skeleton to the web page, and then the web page uses like JSON API routes to fill out the rest of the web page with its data, putting the HTML elements after the page loads using JavaScript. So that's kind of the difference between what we're doing here. So keep in mind, we're running our add message call. So once we have our message that we're going to send, in jQuery, this is how you submit a post request to a server. It's $.post. So post method takes in 3 arguments. So this first argument is a string. The second argument is a string also. And this third argument is a function that will run whenever this completes. So it's going to post to this URL endpoint /add message. Remember, we mapped the post to add message route in our Spark method. The second parameter is the data that it's going to send as a part of the request, which is the JSON version of this message object. The way that most browsers support to turn a JavaScript object into a JSON object. This JSON object to the server with our request. And then when the server is done processing a request and it returns to us like a 200 OK message, right? This is the function that's going to be executed. Then when it executes its function, it's going to pass us any data that the server has back for us. Like if data wanted to send us back anything, it would be passed through that parameter there. We're not using it here. Basically, all we're saying is that whenever we submit a message and we finalize the submission of that message, when the server responds, we want to clear out what the value of our text field is. We had a to-do list or whatever. Whenever we would add a to-do, we would always clear out the to-do text so we don't just keep adding empty to-dos here. So calling val with an empty string. So val with no string gets the value, but if you pass a value into val, it'll set the value of that field. Val is just setting it to empty string, right? So you want to look at it? All right. So let's run our code. We have author has been, the text is test text.
I got HTTP over here. 403. Where it says like problem accessing /.
Me too.
Forbidden.
I know the first time I tried on it.
Did you add that external file directory? External static directory here, this line on line 44 here, external static file location.
Yes, and I have a public.
The public folder is in the root of your application. Are you getting that when you load the page at the beginning or after you submit anything? It's when you just load the page.
Are the jQuery public folder?
They're inside public scripts. Yeah, just bring your laptop over here. I'll take a look at it. should be able to just figure this out real quick and keep going. Yeah, this is in the wrong place. So you put your previously our index.html has been in the resources templates folder, but these are server-side templates that are being processed by Spark. In this case, the index.html is not a server-side template; it's something that's exposed to the public, so it's just here in the public directory.
Oh, so we don't even need a resources folder?
No, not right now. Yep. The problem was that he was putting each index.html in the resources templates folder, which is historically where we have put our HTML files. However, they were there because they were being processed by the server, right? So the server needed an HTML file, and then it sent the generated HTML back. The file was actually a mustache template, and then the server converted that mustache formatted HTML into actual HTML. In this case, we're not doing any server-side templating right now. We're not there's no mustache in this HTML. We're not processing on the server at all. We're just delivering a static asset to the client. So static assets typically, again, are JavaScript. In this case, we're including HTML in that. So we're not processing the HTML at all. We're just sending it back to the client. And so we're going to put our HTML in the public directory right next to all of our JavaScript and CSS and stuff like that. So when I submitted this message, I actually did get an exception. The exception was related to message class. So I created a message constructor that has parameters. And so the JOD parser threw a fit because it couldn't build a message object with no parameters anymore. Keep in mind, remember that by default, the Java runtime gives you this parameterless constructor that does nothing. Constructor for the current class, it no longer injects that parameterless constructor into your class. So if you want both, you have to add that empty constructor back. So internally, the JOD parser was the first step it was trying to do was make a new message, and it couldn't find a parameterless constructor for message, so it was like, problem, right? The JOD JSON library, just because of the way it works, always requires a parameterless constructor. I don't know. I'm not sure.
Why would you need both?
Well, the way that we want to use messages is that when we make a new message in our code, we are specifying an ID and author and text. So that's the way we want to be able to make messages. But the reason why we need to add a second one here is because when I received JSON from the client, the library that we're using, the JOD JSON library, when it performs this process called deserialization, which takes in a string, converts it into an object, exception. Because the exception text was that the default constructor was not found. So internally, we can surmise, based on that information, that the JOD JSON library, at some point, to give you a new message object, it makes a new message object. A custom way for messages to be created, that default way for messages to be created is discarded. Had nothing, it couldn't do anything because it couldn't build a new message object.
On its own terms.
Yeah, and so we specify here, it says, okay, because of that, because we still want to use the JOD library to accomplish our task, we need to add a parameterless constructor, deserializes that JSON into an object, and then it goes and it tries to make a new message. It succeeds making a new message. Yeah. All right. So let's see, let's rerun our app. probably just did. Let's do it again. Doesn't take very long. Let's look at our network pane here, and we'll clear all of our current requests. Let's say Ben test text submit log, because it just resubmitted everything. So Ben test. So let's see here, we have one of these guys is called an XHR. So this is basically how you know an AJAX request was submitted. We call it AJAX. Okay? The way that you submit an AJAX request, and again, this is a relic of a previous time, right? But this is still a de facto standard from a browser standpoint. There is a class, you can think of it as a class in JavaScript called XML HTTP request, right? HTTP request XHR. So you see XHR, you can think to yourself, this is an AJAX request, okay? So since we're using jQuery, we don't have to worry about using an XHR object to submit a request and get a response and all that stuff. We're just saying jQuery post message to data to URL. And it's like, okay. Since we have our DevTools open, we can see what we sent to the server and what we got back. So we can see here that the data that we submitted is this. So author Ben text test, right? So this is the JSON that the server parsed. And what we got back was a 200 OK message. So we know that everything happened just fine. So if we go to dash get messages, which was the get endpoint object, we get an array here, and it has both the indications as before, right? So I've submitted, in the database, it has 2 entries, JSON entries, right? So this is an endpoint that contains all of our data so far. Keep in mind that if we want to ensure that what we are sending or what we're getting back is valid JSON, there's a website called jasonlint.com, which we can paste JSON and it validates it for us. So click validate JSON and it says it's valid JSON. Yeah, it's pretty cool too. Yeah. So the problem with that though is that if you're viewing large JSON documents, that can really be very make your web browser crash. And that's happened to me a lot. So I opt to just view the raw data and parse it in
Chunks.
Yeah. So now when we load the page, we don't want to have to just go to get dash messages whenever we want to see our data, right? That's kind of lame. The end user is not going to want to be able to see, just look through JSON objects to find their news feed or something like that. Like if you had your Facebook feed and it was just a giant chunk of JSON, it would be way less easy to use than just saying HTML, right? So you don't want people to say get messages. You want them to see HTML. So the next thing we're going to do is write some more JavaScript that gets our updates our HTML, basically, right? So we have another element here called a div. Div, it might be short for divider. Hold on. A div element has no special meaning at all. Represents children. So yeah, div doesn't mean anything. It's not short for anything. It just divides the markup into. So the way HTML works is that you have elements that semantically describe the contents of what's inside of it. So for here, for instance, we have an article, this is an article of text. When I made it bigger, everything went all haywire. So inside this, we have an H1. So this is the headline of the article. This is a paragraph in that article. When you don't really know, when you have no other alternative in HTML to semantically, more appropriately semantically describe your content, you can just use a div. Like, so if you know you need an HTML element because of how your code is laid out, but you don't have any information about what that side of it, then you just use divs. In this case, we're using a div, but it very well probably should be an unordered list, since we're going to be sorting a list of messages, right? Not the best choice here, but we're.
I noticed that you put the format is different. You got script at the top instead of at the bottom.
Yeah.
So then it doesn't matter the format of your HTML.
Well, it does. So we'll talk about that too. So let's remove this from the head. So when you have your JavaScript up there in the head, it's going to the browser, before it can get to your body. Think of like a method call, right? In Java, like when you call a method, it goes and runs that method. You're not going to get back to this point until after you finish execution of everything over here. So when you put JavaScript in the head element, it's going to go and get the JavaScript. It's going to download the JavaScript. It's going to parse the JavaScript and execute the JavaScript, which takes time, right? So that takes some time to go and do all that stuff. And it's going to do all of that, make that round trip, execute that JavaScript before it executes the next line of HTML. So it's going to pause that whole process. And so it has to do that for every script that's inside the head element. It's going to go and get that JavaScript, bring it back, execute the JavaScript. That you delay what the user eventually sees.
So that's the lag.
It could be a contributing factor to any latency that you see in a web page. So people have started delaying their JavaScript loading until the end of the page, so that there's nothing keeping a page from showing up immediately to the end user. Like on something called user perceived latency. So this is a thing that's a pretty big topic in web development. People have a really short attention span, like stupid short. Like I know me, if I'm browsing Reddit and an image takes like longer than 2 seconds to load, I'm like, well, I wasn't really interested in watching that anyway. Yeah. In fact, there's a talk that I like to reference all the time from a guy at Google, an engineer whose name's Ilya, who's responsible for load times on mobile devices. So the talk is on breaking the 1,000 millisecond barrier and all the steps you need to do to make sure that you deliver a web page in less than 1,000 milliseconds. Because studies have shown that, the more time it takes to deliver your website, the more people that just bail. They're like, I wasn't really interested. That's basically, the internet is basically a study in how flippant people are about the choices they make. Like, they're probably like in their underwear, right? Like just whatever, right? So that's the process here, is to deliver to them the HTML as quickly as possible. So we're delaying the loading of these script elements until the end so that they'll start to see the HTML. And then afterwards, it'll add that dynamic JavaScript functionality.
So that these kind of pages like load.
Yes. So if you ever see a page that I don't know, you see some elements before it's ready, it's hard to describe exactly what's going on. Actually, yeah. So what you can do is if I want to go to cnn.com, for instance, tools. Otherwise, it's a responsive website, so it looks. So if you reduce the width of the window, it'll dynamically resize the page, which is pretty cool. So this is what it looks like on mobile. This is what it looks like on I guess my screen width isn't big enough for it to not be mobile. But anyway, so what I wanted to show you was this.
Sorry, is that dynamically whatever, that's JavaScript language?
What I said was a responsive design. The website is one that delivers you a web page, and then based off of the width of your browser, it looks as though it's a mobile web page, and then if it's a larger browser, then it's not a mobile web page, but it's the same web page.
So that's written in any language and change that.
That's CSS and HTML, and that's actually pretty like HTML, like it's mid-level advanced stuff. So we won't really get to that too much, but basically that's a characteristic of responsive design.
So you said you were showing us.
Yeah, so what I want to do is show this feature that Chrome has called network throttling. So you can see here that we have like really bad internet. So we can pretend, we can load our page as though we have really bad internet, right? So refresh our page.
So, this is a pretty good way for the developer to test computers. I like how fast their program will run on certain computers and certain internet.
Yeah. So you can see that this takes freaking forever.
Yeah, this is like very intense page.
This is a big web page.
Yeah.
If we make this a little faster. So this is a 2G network. It's downloading. It's still just freaking forever.
And so like,
So you can see, yeah.
if you wanted to like a web page to be able to run on like, elementary school computers, you would make it like less intense and like test it out this way. It's like, it's like computers that don't have.
Yeah. You don't frequently design for slow computers on the web, because most computers nowadays, if they're around, they can handle almost all web stuff, unless you have a very complicated.
The only thing I've seen is like Gmail offers a regular HTML
Yeah.
page rather than like the old one. Or it's like the rest never really gets an email.
I've seen the same thing. So with Gmail, if it detects that a page is taking, like your inbox is taking forever to load, I don't know if you guys have ever seen this, it'll be like, hey, so there's a other version of our web page that's like really utilitarian and doesn't contain a lot of fluff. So it reduces a lot the amount of stuff you have to download. So you can just like get to your email faster, right? So yeah, but page speed is a big deal. There's a lot on the internet about page speed. There's things you can do about increasing your page speed. A topic that I'm very passionate about, but it kind of is out of scope for the class. But if you guys want to sit down and talk about it, like maybe after lecture, then I totally would love to talk about it. In fact, I still want to talk about it, even though I've already explicitly said we're not talking about it.
Using yourself.
Yeah. Okay. So that's a way for JavaScript later in the body element actually will asynchronously load that JavaScript onto the page, so it won't block the parsing of that HTML. So you'll see something sooner, right? So that's key. So in our chat.js, we're going to increase the functionality of that to call get messages as well. Hold that so it's out of our way. So get messages. We're using jQuery again here. A post method, we're using a get method. So we're sending a get request through Ajax to this get messages endpoint. And in this, we're actually going to be using this data parameter here that comes back. So this second parameter here, what will run when we successfully conclude our request. Okay. So this is an asynchronous request. So this get method is going to run and then return immediately. If I did this, what's going to happen is that get method is going to run and then return, and then while that message is on the server somewhere, going. So the JavaScript runtime is going to run line 17 and then immediately run line 32 before that request from the server comes back. That's what makes it asynchronous. Okay. So synchronous versus asynchronous. Right? Synchronous means that in order for method B to run, method A has to finish. A runs while A is running, B can run. All right. So at a high level, that's the difference between asynchronous process and the synchronous process. All right, in all of our code we've written so far, we've done synchronous code, right? Everything up to now, except for one small thing we've done with threads, has been synchronous. So in order for line 5 to execute, line 4 has to be done. So on and so forth throughout the course of your program. So this is a new concept. The client side, frequently you will kick off asynchronous processes that will return at some point that's not under your control. As the client, you have no idea when the server is going to give you back your data. It could be 2 seconds. So you don't frequently want to have a synchronous process because that would hold up the entire loading of your web page for that length of time. So you're like, go get this stuff. Whenever you get back, we'll do something cool with you, but we're not going to wait for you to give me back our data because we've got other crap we want to get done, right? So that way, if we want to do 5 cool things simultaneously, and eventually all 5 of those processes will come back and you'll run all this stuff to give you all of your cool data. But in JavaScript, very rarely, when you're and stuff like that, are you going to want to run synchronous JavaScript.
So if you run 4 or 5 asynchronous things.
Yeah.
So say console.log test was an asynchronous function as well. It's data before the get. It would run whatever's in its curly brackets before, then after. So you send away for
Yes.
the responses. When you get your responses, if the response from the B, so the lower one, comes in first, that's going to run. Or is it going to wait until the response from this is run? Like, are they going to sync back up?
No.
Okay.
So that's why you have these callback methods. So like, you could check this out. You could have this right here. So instead of this, you could have 2 get methods. Same time, and then return arbitrarily. There's no way you can decide which one will come back first. So like on success, this will run this function, and down here, this will run the same function. But as for on first, it's not. It's up in the air.
Whatever.
Yeah.
Okay.
Yep. Like you could have like a get endpoint, and you could pass in a query string. It's like a delay. Process a delay and just wait. Thread.sleep for like that delay length, and you can see that in action. That'd be a good experiment if you wanted to do that.
Okay.
Yeah. So on success, which is the second parameter to this get method, we're going to be doing stuff with the data that we get back from the server. So jQuery is going to give us this data in this data parameter. We know cognitively that what we're going to get back from the server is an array of messages. And it's 11 o'clock. Okay, after we run over get messages, we'll take a small break, okay? And then I guess we'll just save spring for tomorrow. So we're getting into spring. Yay! Right, okay. So function operates on data. So the first thing we're doing is we're getting a reference to this messages div. Remember we made that div, we gave it an ID of messages? This is how we reference an HTML element with an ID, is this hash element with the ID name here. This empty method in the jQuery language, or the jQuery framework, will trash anything that's inside of that div. Basically, it empties it out. So like if I had stuff in here like test stuff in div, right? It's going to just trash that H1. Completely empty it of any data. Okay. So once it empties out the messages, we want to get this messages object. So what the server returns back is a JSON object. And then we can convert that JSON into a JavaScript object by calling json.parse. So we had a parse on the server, take a string of JSON, and you turn it into an object. It's the same parse method here. You're parsing that string, turning it into an object. On the server, we have serialize, which is an accepted general way of turning objects into strings. And on the client, we have stringify, which is someone made a decision to call it stringify, and it's dumb.
Yeah, I didn't know if that name was real or not.
Oh, it's real. It's a thing, for sure. Yeah. I mean, it doesn't make, you'll remember it, right? So it's silly and it seems dumb, but on the other hand, it's memorable. Right? So everyone always knows JSON.stringify because it's like, God, that's so dumb, right? But it did its job really well, right? So how dumb is it really? Mind blown. All right. So just like in Java, JavaScript, which was supposed to be Java-esque when it was designed, but with lots of added features, has an alternate for loop syntax. So there's a standard for loop syntax in Java, but there's also this var I in messages. So this will take every message in our messages array, right? And call it I. So we have var author is messages I dot author. Is not behaving as this author intended it to behave. So I'm going to revert this real quick. This lesson, that for loop just made me cringe too hard, so I had to get rid of it. About what made me cringe later, but basically we're going to revert back to the original for loop syntax. Okay. So this makes a lot more sense to me. Basically, we have var author here. Keep in mind that this is a common thing in JavaScript is we don't need specific data types like integer and string and or object or anything like that. On the front end, it's just a var. Okay. And in fact, nowadays, there's a new variable called let. And the difference between var and let is another topic that will a lot of stuff like on one-on-one conversations. But for now, you can just use var, okay, to declare your variables. Declared with the function keyword, variables are declared with the var keyword. It's pretty straightforward, right? So var author is a author variable that gets its value from the ith element of the messages arrays dot author. And text gets it from the text field. Then this var lm is a new div element. So in jQuery, it doesn't just select data. You can create a new div element, a div in brackets like this. Okay, so this is the reference to a new div element. So once we have an element, we can actually set its text to whatever this value is. So we got our author and text from our JSON. Add those three strings together. So author, and then a colon, and then a space, and then text. So it's author, whoever wrote it and what they wrote, right? And finally, right here, we're getting another reference to our messages div. append that element to the messages div. So keep in mind that what you see on a page is a tree of elements. So at the root level is the HTML element. Inside that, it has one child, the body, and the body has potentially like hundreds of children, right? So if you make a new element arbitrarily, like we're doing here on line 26, it's not going to be visible on your web page just because it exists. You have to attach that element somewhere in the tree in order for it to exist. Okay. So that's what we're doing here. We're appending to our messages list the element that we created.
Sorry, you said inside the body. Could you restate that tree again?
Sure. It'd be easier if we looked at an actual example. So if we look at an example of HTML, it's actually pretty heavy. This is the TO website. So the HTML on the element on the TO website is pretty complex, right? We have lots of libraries that add these elements, class names to this, okay? So don't worry about that too much. The direct descendants of elements are head and body, okay? The descendants of head are all these meta tags, all these script elements, okay? The descendants of body are, first, we have no script, which is a block to describe what to do if the browser doesn't support JavaScript. Too much technical detail of what these contain. The body has a bunch of div children, a bunch of script children. It has an iframe child. So this div element has a header, a section, and a footer series of children. This header has a child. It has two children, a div, header div, and a color div right here. I'm not sure why they did that. And then this div has 1, 2, 3 children as well. See, that's any HTML element that exists has one parent and many children.
That one parent is the head, or is that the HTML?
No, sorry, they don't all have the same parent. Like this guy's parent is this div. So any element that exists in HTML has one parent and many children. It makes it very similar in computer science terms to a data structure called a tree. So if you look at a computer science tree, trees look like this. So they start with one parent element. So each node has a parent element except for the top level one. Right? So in order for the browser to show your element, it has to be attached to this tree. So if you create a new element, it's not going to be displayed by default. Like just because it exists doesn't mean it's going to be displayed. You have to attach it to the tree to give it a position for it to display. Okay? So it's a long-winded explanation for why that exists. All right. So should be all good to go. Actually, what we're going to do here is this last step here is called a set interval. So set interval specifies a method that is run every number of seconds. Okay, so this is the method that's going to get run, and this is the seconds between every time it's going to try and run it. So this is basically the same as that Lambda expression we wrote before in Java, where we had to write that functional interface, and then we made a new local variable of type functional interface that we just created, and we made a Lambda expression that like implements that functional interface. In JavaScript, you just function, and that basically is doing the same thing. JavaScript makes it stupidly simple to just pass around functions, just like regular variables, and blows your mind, especially if you come from like a classical programming model where you don't ever do that, like I did. When you first see that, it's like you got to take a minute to think about what the hell is happening, because it totally messes with how you perceive your world. So yeah, this is going to run the get messages method every 1,000 milliseconds. So every second. 10 seconds? JavaScript. Set. So delay is a number of milliseconds, thousandths of a second. So yeah, milliseconds to thousandths of a second. So yeah, it's going to be 1 second. So if you want thousandths of a second, it's 1 second. Right. So we run this. Technically, we don't have to rerun the server because we're just doing client-side stuff, but I'm doing it anyway because I am paranoid. We reload our homepage. And we actually have a problem here. Yeah, it should have. So we're going to check out what happened to our console. So it's failing to load chat and Jake. Oh, it's because we copied the text from the lesson instead of copying the elements in our div. This we put them in the scripts folder. Oh yeah, that's true. Good call. And then this has to be capital Q. I'm just starting to pick up on stuff. It's scary. All right, so we get a message in our console every second or so, which makes me think that maybe that's in our get messages method. So if we go to chat.js line 23, we can see that I made an error when I rewrote the for loop, and it's messages at i.length, rather, not message.length. So I need to go back into chat.js, and our get messages method changes to messages.length and update it. Oop. So this might be like one. You might have like a span. No. P. Let's do a P tag. P is paragraph. So it says loading. Add that there, just for fancy measure. Right? Pretty cool. So Ben, Ants, Submit, Ants. Talks about this is that, well, hold on. First of all, we can open up new tabs. So let's open up a new tab here and go here. I submit something here, say Mike says, this is so freaking cool, man. You hit submit. The page reloads, and then you see it updated over here. Okay. So if I'm gonna do this faster. So I submit here. It did it so fast. Just open up this like right here. Okay. Send those away.
Yeah, so hold, so go to like the green maximize window, but hold it, like hold. So do that to that side, and then click that one.
That is, I would never discover that.
Yeah, it's not, I think the it's not great.
How do you get rid of it?
If you go to the top, you
If you just like, I guess not, if you click the green button again on either window, it goes away.
you click and hold the maximize.
There we go. Because every time we submit this form data, it actually is reloading the page.
Okay.
So the form action wasn't specified, so it's just, and it's by default, the forms are get methods, and so that's why this question mark exists furthermore. I'm actually going to address that now. So every time we add a message on our current page, it like reloads the page and says loading again. And we kind of want to get rid of that. So the reason why this is happening is because we have our input text fields and our button inside of a form. That form is missing its action and method attributes, and so by default it's defaulting to the current page with a GET request. But when you hit submit, it's going to just refresh the page. right? So when it refreshes the page has to go through that JavaScript again. By default, it has that loading text. So that's why you see loading every time you click submit. More, because we don't need it. Because the submit button, really all we're interested in is the JavaScript that's executed when you submit it. So an ID to the submit button. I'm going to say submit button, right? Yes. I'm going to do this. I'm going to add what's called an event handler. Oh God, I didn't copy that apparently. So when I click on that, I want to handle the event. All right? So this is how I would attach an event handler. So when I click on the button, this function is going to run. So event objects in JavaScript have methods on them to work with events, right? Which makes sense. If you have an event class in Java, you'd expect that class to have a bunch of methods in it that let you reason about events in JavaScript. And one of the things you can do in the event default, you can also stop propagation. Let's see this in action first. Hey, Ben is the author, and the text is pants. I submit. It says pants, right? But you see, it didn't reload. There's no reloading text. And in fact, I'm going to open up my while our program is running. We have an interface to H2, and I'm going to delete from messages. So next time I load the page, it has nothing. Okay. So Ben is text. Eventually it says Ben test, right? But you see there's no loading page anymore. There's no no loading. It just happens. No longer submitting the form to the server. So it's no longer refreshing the page. And I want to talk to you more about these two lines here and how events work in JavaScript. But I said we were going to take a break. That was 15 minutes ago. So let's go ahead and take a break. Come back around 11:30, and we'll spend the rest of the time talking about cool JavaScript stuff. No. Yeah, sure. You convinced me.
And I'm gonna get a full screen. Push the button down. What'd you just do?
Push that button.
I did that. Not sure what I'm missing to make it. When I try to load mine, the messages don't show up,
Okay.
and that's most of them.
Do you mind if I open up Chrome here to look at this? Because I'm much more familiar with Chrome. You have Chrome installed, right?
Yep.
Okay. So, yeah.
What did you do to split the screen again?
Just then?
Yeah.
This is not splitting the screen. I'm just opening the dev console.
Yeah.
Yeah, so I hit Command Alt J.
Okay.
Yeah. So first of all, our first problem is that it can't find the jQuery JavaScript file. So look up here. Our public directory, we should have scripts jQuery. So yeah, you just called it jQuery.js, which is fine. We just have to update our index.html to say jQuery.js. Okay, refresh this. So unexpected input. Yeah, we have a weird syntax error at the end of the chat file. So let's just get rid of this guy here. Refresh the page again.
So then how was it?
Looks like we still have a syntax error here with our. Yeah, we're missing. Function add message, we'll get messages. Yeah. There we go.
Oh, that was really simple,
It's okay.
kind of simple.
But we're not actually working yet. Hmm. Okay, so we must have this. Yeah. So you put the p tag outside of this div. So it needs to be a child of that div in order for it to go away. Right, so that's why I was waiting for it to go away, but it wasn't ever going away. That makes sense. So you can add that prevent default stuff now if you want to. Yeah, but now it works.
Thank you.
You're welcome.
So, what do we have for?
What do you need them for? Well, nothing, man. We don't. If you want to become a dude that can handle all the front end stuff and the back end stuff, then be that dude. People will throw money at you, almost literally. They will want to throw money at you. They'll be like, please come work for me.
If you do what again?
If you are, so what Mike is describing, he said basically his question was, so why do we need those guys? Pointing to the front end class.
No.
Right. And the answer is you don't have to have them there, but it is very useful to have them there. It is extremely rare to find a developer that is proficient in front end and back end. So I am kind of a quasi full stack developer, kind of, not really, right? Like my expertise is definitely on the back end of things, and kind of the back and the middle, like the layer between client and the server and the database is really kind of where my expertise lies. Like when it comes to like making like a new CSS website from scratch, I'm not a fan of that. So that's usually like the front end. They get really deep into like HTML semantics. They get deep into like CSS selectors and how to write valid CSS. They get deep into like preprocessor languages like Sass and Less. And while it's useful as a back-end developer to have a working knowledge of all those things, it's usually the type of person that is a back-end developer is less interested in like diving deep into the CSS and tweaking it until it works. Usually, you delegate that to a front-end person. But like being a good developer means understanding the system at least at a high level, right? So having a general knowledge of how these things work, like how HTML works, how JavaScript works, how CSS works, is important. But you're never going to be a master at CSS, details of CSS, right? So typically, a lot of times people just delegate responsibility like that, front end, back end. And there are frameworks like Twitter Bootstrap that lets you pretend like you know what you're doing on the front end really easily. Avery, do you want to share with them the work you've been doing recently?
Which work?
The Spring Hibernate Angular work.
Okay, yeah.
So while you're pulling that up real quick, I just want to talk about what's happening here. So when we click on this submit button, we're handling that event with this function called here, this EV object. So on this object, which stands for the event that's fired, we're preventing default. So prevent default is a method that will prevent the default action of that click from happening. So like, if you have an anchor element, the default action when you click it, go to that page. So if you want to stop that from happening, you call prevent default. Thing is stop propagation. So when you click on an element, we looked at that before, computer science tree. Hold on, Chameleon bound tree. A more useful visualization. Yeah, it is. So this is more along the lines of what the tree looks like in an actual HTML document. So everything's in HTML. HTML has head and body. Head have meta, title, style. Body could have, like this is arbitrary, it could have anything. But in this sample case, it's H1 and section and footer. If I clicked on this this strong element here. Strong is how you define, that's just how you mention emphasis in HTML. If I click on this, I've clicked on this, and then by default, it will propagate to its parent. So it will fire here, and then after it's done here, it'll fire here, and then it'll fire here, and then here, and then here, and then it'll be done. So events bubble up, they propagate to the parent element, okay? Unless you stop it from happening. So when I called that, I was like, if I click this, I don't want anyone else to try and handle this. I'm going to stop it from propagating to its parent, and I'm going to prevent it from actually doing anything that it does by default. So it's not going to submit the form, and it's not going to propagate the event. So basically, it's just stubbing out. It's like, I'm handling this. It should not do anything else. So you call those two methods, and it performs that function. Right? So there is more stuff to do with events. Like there's something called a capture phase, which actually will fire. You can trigger events to fire on its way down as well, but that's very rarely used. But stop propagation does that. It keeps it from propagating to its parent. Cool? Sound good? All right, so before Avery shows his work, I actually want to thank you once again, Adoring fans. I'll see you when I get home.